Welcome to the experimental video for the synthesis of isomer A of potassium cobalt IDA. Weigh off 1.6 gram of potassium hydroxide pellets. Remember, this does not need to be done completely accurately since it will be very difficult to weigh off 1.6 grams precisely using these pellets. Thereafter, finely crush using your mortar and your pestle. Ensure that you have a very fine powder. Also work quickly since your potassium hydroxide is quite hygroscopic and will quickly absorb water if left too long to absorb any moisture from the atmosphere. Using your measuring cylinder and the distilled water bottles provided, measure roughly 6.5 milliliters of distilled water. You will use this distilled water to transfer your potassium hydroxide to a 100 milliliter beaker. First, try to scrape as much of your potassium hydroxide using a spatula into the 100 milliliter beaker before subsequently using the water to transfer all the remaining potassium hydroxide from your mortar and pestle into the beaker, as we will illustrate now. Rinse your mortar and pestle as well as your spatula with the 6.5 milliliter of water, and then transfer that water to your 100 milliliter beaker to ensure that you've transferred all the potassium hydroxide that you weighed off earlier. Continuously swirl the solution until you have a completely homogeneous solution, and homogenized solution, however you would like to pronounce that, meaning that your solution is completely clear. Next, we will need to weigh off 2 grams of our amino diacetic acid, which will be our ligand in this case. Usually our ligand is in excess to allow for complete coordination. Transfer your amino diacetic acid to your perfectly homogenized solution and continue to swirl until all of your ligand has dissolved. This might take some patience and a lot of swirling on your part, but please ensure that all of the ligand has dissolved before you add your cobalt chloride. Ensure that when you swirl vigorously that you do not spill any of your reagents. Next, we need to weigh off 1.7 gram of cobalt chloride, cobalt 2 chloride. It should be a dark purple or wine red, depending on what color you would like to see. Now add your cobalt chloride to your perfectly homogenized solution and swirl once more until you have another perfectly homogenized solution. This solution should be a very intense wine red solution and should be completely free of any particles that have not yet dissolved. Next, we need to prepare our ice water bath, which will need to remain at approximately 12 degrees Celsius. Start by adding some water in one of your plastic bowls. Measure the temperature of the water at room temperature to establish what your baseline temperature is. In other words, how to estimate how much ice you will need to add to lower the temperature to 12 degrees. Estimate the amount of ice you need to add and try to keep the level around about 12 to decrease the temperature to around about 12 degrees Celsius. Do not go below 10 degrees Celsius and not much more than 15 degrees Celsius. Remain within this range for the entirety of the reaction process and the 2 to 3 hours that you will keep your reaction flask in this. As you can see, our temperature of our water ice bath is around about 12 degrees Celsius, and hence we will place our reaction vessel into this water bath. We can use a glass rod to allow some seed crystals to form at the bottom of our flask to aid in the crystallization process, as we have done in previous experiments, which you should be familiar with. As always, remember, be careful to do not break the bottom of your beaker, since this will destroy any chances you have at forming a clean product. You also should have collected your 5 milliliters 15% hydrogen peroxide by now, and you can start adding this dropwise while either stirring or swirling your reaction mixture. Hence, add a few drops at a time. You must do this slowly and then swirl or stir using your glass rod. Continuously stir and swirl while adding the hydrogen peroxide, and always remember to monitor your temperature so that your bath never goes over about 15 degrees Celsius and always never below 10 degrees Celsius, since you always need enough energy for the activation energy barrier to be breached, but never too much energy for the activation barrier to be overshot. After about 2 to 3 hours of your continuous swirling and seed crystallizations, etc., you are ready to wash your product using vacuum filtration. So as always, you have your Bochner funnel clamped at the back of the fume hood, and now you will wash with some ice cold water and ethanol. We used ethanol, pure ethanol in this case, one aliquot of 5 milliliters and another aliquot of 10 milliliter. To ensure that you transferred all your product, you can swirl some of your washing material in your reagent flask or your agent beaker and transfer that to your Bochner funnel, and then again wash your product. Your A isomer should be a purple color if done correctly, or at least the activation temperatures done correctly will give you a purple color, a nice deep purple color. Finally, after leaving your crystals or your powder to dry on the vacuum for a few minutes, you can further leave it to air dry on a watch glass. Transfer it from your filter paper to a watch glass, and remember, this needs to air dry, and specifically air dry because you cannot place it in an oven or on a hot plate, because that would favor the thermodynamic decomposition of this isomer to another isomer. Why? That is exactly the point of this experiment, and I hope you followed that. So please do not place this in an oven. Remember, after you have dried, then only can you determine your mass and your yield. Thank you for watching.